All right, here's another one that is a complex or combination circuit, and we're trying to find the overall resistance. So as before, we're going to start the positive end of the battery, and we're just going to go along and see what happens. The first thing I encounter is a resistor. I have no choice. I must go through this. So I'm going to say, okay, we're going to start with 15. At a minimum, this circuit's going to have 15 for an overall resistance. Then, at this point, it branches. So anytime you see it branch, you should try to figure out, well, where does it come back? So I can either go down this path, or I can come along this path, and they meet back up here. So then we analyze each of those branches. So down one branch, so this is a parallel part of a circuit, because you have two options. So down one of the branches, I have a choice. I have 5 ohms. So that means, essentially, that I have a 5 ohm resistor, and down the other branch, I have 2 resistors in a row, one after the other. So if I choose this path, I have to go through the 10, I have to go through the 15. So essentially, these two together are really like a 25. If you have to go through one, you have to go through the other. So on my branches, I have a choice. I can either go through a 5, or I can go through essentially what's a 25. So that is what is in parallel. I have a 5 in parallel with a 25. So I'm going to say, okay, 1 over 5 plus 1 over 25 equals, I'll get my decimal answer for that. So that's going to come out to, I believe, 0.24. Yep. And then I'll take the inverse of that, 1 over 0.24 equals 4.17. So that means from this point to this point, the resistance is equivalent to 4.17. And I have to go from here to here, so that's going to add 4.17 to my total. So my overall answer is 19.17 ohms. That's my total resistance. So the common mistake people make on this is they recognize that this is parallel, that it branches here and turns here. And then they say, oh, there's 3 resistors in this setup. And they start saying 1 over 5 plus 1 over 10 plus 1 over 15. That's always the first thing they jump to. But the 10 and the 15 are not in parallel. These are on the same line. So that's why you have to add them first. In order to have 3 fractions, you need 3 separate lines. In other words, if we wanted this to happen, I would need a 5, I would need a separate line with the 10, and a separate line with the 15. So that you got a choice of 3 different paths, not 2 different paths. If there are only 2 paths to choose from, as there are here, you can go down to the 5 or around, then you only are going to have 2 fractions. So just got to be careful with that. If going through one forces you to go through another, you add them together. They're in series. So common problem, just be careful. This is, again, how you solve a complex circuit. So until next time, I am Derek Genova. Have a delightful day.